Hypothalamus Artificial Intelligence, HI, presents the conference Artificial Business Management. Part 2. Decision-Making Artificial Intelligence. A new way of looking at artificial intelligence that will change the world as we know it. Conference for Managers and Executives. WHO want to know the future of business management. Human intelligence and artificial intelligence. As the name implies, artificial intelligence is the result of the scientific effort to provide intelligence to machines, to replace the systematic processes carried out by humans. Today, artificial intelligence takes the form of high-speed mathematical algorithms, implemented in the different types of computers available. And it's the result of modeling human intelligence from biological neural networks, which are a fundamental part of our brains. But there's no denying that this view of intelligence is limited, as it only looks at one element of the human brain. Recently, innovative scientists, like Jeff Hawkins, have begun to look at artificial intelligence from a new point of view, integrating the structure of the cerebral cortex into previous knowledge developed for neural network. Based on Hawkins' studies, and HI's experience, Jesus Velasquez Bermudez, CSO of HI, began in 2017 the process of integrating a coherent theory to unite the concepts of neural networks, with large-scale optimization, and with structured mathematical modeling. To this end, neuroscience studies and the structure of the human brain have been reviewed. The result is a coherent theory for the implementation of artificial brains for companies, following the modeling principles of enterprise-wide optimization. This gives rise to a new vision of artificial intelligence, which HI has called decision-making artificial intelligence, which will support artificial business management. Human intelligence has evolved along with human beings. From an incipient basic intelligence, in the origins of human beings, that needed to see to believe, to a highly developed intelligence, with intuitive scientific ability, which can mathematically predict the behavior of the universe, without having to perform verification experiments. This is the case of Einstein, who, after experimentally demonstrating the theory of relativity, developed multiple theories that history was responsible for demonstrating. To understand this process, HI describes human intelligence as composed of three intelligences. Mental intelligence, basic to all human beings, oriented to the recognition of patterns, without an understanding of why it identifies them. Mathematical intelligence, which is developed by trying to understand why these patterns occur, to explain behavior in the real world. It's not innate, it requires math, starting with algebra, all the way up to parallel math, which today's big computers require. It focuses on scientific decision-making. Many humans never develop it. Creative intelligence. It is developed by privileged human beings, who learn to use mathematics to create the theories that are required for the humans to move their mathematical intelligence. Very few humans develop it. Human knowledge is supported by three types of intelligences. Mental intelligence, it is the abstraction or conception of what is perceived by individuals about a given issue or problem. Mental models are constructed with the knowledge, experiences, assumptions, perceptions, intuitions, informal inductions, deductions, and values of the individual. They are elementary models that are not exposed in public and therefore have a validity limited to the individual. They have their origin in the evolution of the human being, hominization, from the most primitive ancestors, Australopithecus, to the appearance of our species as we know it today, Homo sapiens. All human beings manage mental models, very quick to solve, and, in their absence, easily copy themselves from a more influential individual, and more recently, are implanted in human beings through the ochlocracy of mental models distributed by social networks. When intelligence works under this model, we will call it mental intelligence, which exists and develops in all humans. Mental intelligence and pattern recognition. Mental model is oriented to identify patterns, its foundations are not mathematical, and respond to data processing, and evaluation of eventual, and systematic, experiences. It is based on good practices. Pattern recognition is a data analysis method that uses machine artificial intelligence algorithms to automatically recognize patterns and regularities in data. This data can be anything from text and images to sounds, or other definable qualities. Pattern recognition systems can recognize familiar patterns quickly and accurately. Pattern recognition is the activity that most performs the human being, for example identifies images of people, foods, hydroclimatic conditions, traffic conditions, texts, sounds, and etc. All this with the aim of establishing the conditions of the environment, in the past, the present, and the future, and based on this knowledge make decisions. How the brain identifies patterns is not properly known, but it is mimicked by traditional artificial intelligence. The essence of the so-called artificial intelligence is mental intelligence represented from the study of biological neurons. In 1943, Warren McCulloch and Walter Pitts created the concept of artificial neural networks. They published the paper, A Logical Calculus of the Ideas Immanent in Nervous Activity. McCulloch and Pitts tried to understand how the brain could produce highly complex patterns, by using many basic cells that are connected. They designed their system based on as they believed our brains work, and patterned it after the biological model of how neurons work with each other. The neural networks were growing, and in practice they took the name of artificial intelligence, displacing other methodologies and technologies that also generate artificial intelligence in the machines. As the diagram presents it, a neural network is an interconnected group of nodes that allows computers to recognize patterns in data. This area of science corresponds to predictive analytics. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets, specialized in performing specific pattern recognition. For this, the basic patterns of ANNs are modified. Artificial neural network modeling has evolved to the point where networks with specialized structures can perform specialized functions. Convolutional artificial neural nets. They correspond to ANNs specialized in identifying certain types of patterns, such as images. The image presents an example of an ANN oriented to recognize images of numbers written freehand. The result is a discrete indicator associated to the number read. GPT is the state-of-the-art of the standard artificial intelligence. Generative Pre-trained Transformers, GPT, are a family of neural network models that uses the transformer architecture, and is a key advancement in artificial intelligence, powering generative AI applications such as ChatGPT. GPT models give applications the ability to create human-like text and content, images, music, and more, and answer questions conversationally. Organizations across industries are using GPT models and generative AI for conda, text digesting, content generation, and search bots. ChatGPT, produced by OpenAI, is the state-of-the-art commercial artificial intelligence GPT. Is ChatGPT a neural network? Yes, it is. ChatGPT is a natural language processing model that uses a neural network to power its understanding and conversational responses to users' text prompts. Specifically, ChatGPT works with a large language model, LLM, called GPT-3, developed by OpenAI and which has 175,000 million parameters. This is due to the current computational power and the great availability of data on the web. ChatGPT uses a feed-forward neural network as well as a normalization layer to generate its human-like responses. The feed-forward neural network applies a nonlinear transformation to the input stream, ensuring that the model can learn complex patterns in each dataset. The normalization layer stabilizes this training process by making sure that the input values have a relative scale size. It uses a machine learning technique, called fine-tuning, to ensure it responds to prompts accurately. However, it should be noted that, like any predictive method, it meets certain basic characteristics. You can set the accuracy of what you predict for the sample. In a regression process, this precision is called R-squared. As the number of parameters increases, the accuracy increases. But too many parameters lead to problems of overestimation. Accuracy depends on the quality of the sample, it can never explain what is not in the sample. But their ability to solve real decision-making problems, different from advanced pattern recognition, is minimal, if not nil. For many data scientists, data-oriented models are the only artificial intelligence out there. This includes academic teaching. This entails a problem of development of artificial intelligence, since many executives and managers not experts in AI, think that the only artificial intelligence that exists is predictive. Then, it is applications such as ChatGPT, and the like, that will be considered the AI of the future. Second, mathematical model is a scientific representation which make use of mathematical language to describe or to explain the portion of reality that is of particular interest to an individual. It is the result of the research carried out by certain humans. The mathematical models are growing as analytical tools that provide greater processing speed to the investigation. For its understanding requires formal training in mathematics and in the science being modeled. These models increase the intelligence of human beings, creating large differences, chasms, between them. When intelligence works under this model, we will call it mathematical intelligence. This ability to understand mathematics, and to handle it, does not extend to all humans. It is necessary to acquire knowledge and experience, to handle this intelligence properly. At present, its development is directly related to the ability to handle computational and mathematical technologies. Mathematical intelligence and decision-making. Decision-making process is the final objective of any person or organization, which seeks to make the best decisions from its point of view, its criterion. This process, when carried out in real time, requires a great capacity for mathematical calculation, to handle the complexity of the real world, which increases over time, since the universe increases its entropy at each moment. When humanity began its evolution, it only had mental models to support its decisions, which seriously limited the speed of the evolution of the species, due to the little, almost zero, capacity of mental models, which led the human being to make decisions with very few calculations, or without them. Thanks to analytical intelligence, human beings developed their mathematical intelligence, which has led us to Industry 4.0. For the convenience of the reader, decision-making artificial intelligence, DMAI, will be presented in comparison to traditional artificial intelligence. The first big difference is that DMAI is based on the study of mathematical intelligence, which focuses on the representation of the physical world through algebraic formulas, or through differential calculus, and solves problems using exact mathematical algorithms, aimed at finding the best decisions. This area of science corresponds to prescriptive analytics. The creator of the human brain conceived it as the integration of three main organs, or systems: neocortex, hypothalamus and hippocampus. The hypothalamus is part of the thalamus. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. The neocortex contains millions of neurons that communicate with each other, to capture the world that occurs around the human being. The connectivity of these neurons does not occur based on a dense network that connects all neurons to each other. Connectivity is based on a sparse network, which can be assimilated to a sparse array. Neuroscientific studies associate the network of neurons of the cerebral cortex in layers, and in columns, connected in an organized hierarchical way. In mathematical models, it is common to use a matrix that relates columns with variables, and equations with rows. The normal thing is that these matrices are sparse, structurally similar to that of the human cortex. This section is based on the paper, "Why Does the Neocortex Have Layers and Columns? A Theory of Learning the 3D Structure of the World." Neocortical regions are composed of columns and layers that performs robust object learning and recognition. Columns integrate their changing inputs over time to learn complete models of observed objects. Lateral connections across columns allow the network to more rapidly infer objects, based on the partial knowledge of adjacent columns. Because columns integrate input over time and space, the network learns models of complex objects that extend well beyond the receptive field of individual cells. The image presents the hierarchical distribution of neurons in the neocortex, joining brain, neocortical columns, simple neurons and ion channels. This is the starting point of the Hawkins model. Hawkins proposes the concept of regions, groups of cells organized hierarchically, interconnected, but with a low density of links, sparse. This is the fundamental representation of the 3D connectivity of neurons in the neocortex. This structure has the same characteristics as those generated when a monolithic model is divided and decomposed into an atomized model, to process it in parallel. This diagram shows a 3-level structure, result of partitioning and decomposition of a system, using a simple methodology of large-scale optimization, like Bender's theory or Lagrangian relaxation. Based on the concepts of partitioning and decomposition, it is possible to decouple a system, to obtain vertical structures partially similar like of the human neocortex. The hypothalamus must coordinate all the processes that the human being carries out. The artificial hypothalamus must connect the multiple mathematical models, algorithms, that are part of the artificial brain, exchanging information between them to obtain a common goal, mathematically an objective function. This activity must be autonomous, permanent, and based on distributed processing. Hippocampus store the experience, and the knowledge acquired over time in the human brain. The learning process of the human being is concretized in memory, which accumulates information to face each new situation using the accumulation of knowledge that has been made up to that moment. This information is stored in the hippocampus where the data is organized according to its age. Like any physical element, its use affects its reliability, and that is why short memory, the one that stores the data of the last days, begins to fail with age, until it is lost, while long-term memory can store very sharp data, but that require greater access time to locate them, remember. To handle the concept of mathematical intelligence, Hai developed the concepts of mathematical artificial neural nets, MANN, which complement the concepts of artificial neural networks, ANN. Those interested in the topic can watch the video. The future, mathematical artificial neural nets. The result is the development, by Hai, of a theory for the construction of artificial brains, based on experience and mathematical science. The development of artificial intelligence for decision-making at Hai is based on the praxis of intensive prescriptive analytics. Hai developed OptX, Optimization Expert System, a multi-model optimization artificial intelligence tool, which complies with the principles of an artificial hypothalamus, and the development of methodologies that can be coupled to multi-level mathematical structures, such as those of the artificial cortex, and source code generation, to eliminate manual computer programming tasks. To evolve from mental intelligence to mathematical intelligence, the human being requires another type of intelligence that allows him to perform the analyses to understand and discover the models that govern the universe that is written in the language of mathematics, Galileo Galilei. We will call this intelligence analytical creative intelligence. This intelligence can be considered as the highest level of human intelligence, since it is what allows to grow in the discovery of mathematical laws, and in general new knowledge, which is the engine of the scientific and technologic of humanity. In practice, very few humans have this ability and discipline. While humans in prehistoric times did not have access to mathematical intelligence, because they were creating it, today it is the engine of human knowledge, and ideally should be handled by all humans. Unfortunately, this is not the case. Therefore, its management must be part of the artificial intelligence that humanity is creating. The same thing happens with creative intelligence, the knowledge created by scientists, and the way to produce it is part of today's human intelligence. Proof of the above is the speed with which we produce knowledge. It took many centuries, hundreds, to produce algebra, but mathematical knowledge every day occurs faster, and extends its borders. For example, since 1947, with the appearance of the digital computer, a new science has been created: mathematics for computers, first monoprocessors, today parallels. This must be part of the artificial intelligence of the future. When the previous trend changes, humanity will have begun its disappearance process. Two different worlds. Without fear of being wrong, it can be said that as people and organizations travel the path from arithmetic to parallel thinking, an abyss is being generated, which is concretized in the speed with which a society produces knowledge and wealth. The new way of mathematics is directly related to the parallel thinking, and today it can be said that, like paper-based math, sequential mathematics for single-processor computers will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Alice, which way I ought to go? The Cheshire Cat. It doesn't much matter which way you go, if only you walk long enough. Thank you for your attention.